Okay, continuing with number 5. Which of the following is the solution to the differential equation dy dx equals 5y squared with the initial condition of y of 0 is equal to 3? So let me write that here. Dy dx equals 5y squared at y of 0 is equal to 3. All right, so we need to separate the variables. So we are going to go ahead and divide by y squared or multiply by 1 over y squared, leave the dy on the left, multiply through by dx as well, and that gives me 5 dx. I'm going to bring that y squared up as y to the negative 2 dy equals 5 dx. And then we'll go through and we're going to just integrate the left and the right hand side. It gives me y to the negative 1 over negative 1 equals 5x plus c. So that's going to give me, again, I'm going to go ahead and plug in 0, 3. So I get 3 to the negative 1 over negative 1 equals 5 times 0 plus c. That becomes 0. 3 to the negative 1 is 1/3. Divided by negative 1 gives me negative 1/3. I'm going to go ahead and clean up this left side a little bit and write it just as negative 1 over y equals 5x minus 1/3. I'm going to go ahead and multiply through by negative 1. That's going to make that a 1/3 minus a 5x. On the left-hand side, I am going to want to reciprocate to get that y up top. In order to do that, I must make that right side a complete fraction. So I can multiply that 5x. And there's a few different ways of doing this, but just multiply by 3 over 3. And so that's going to give us a 1 minus 15x over 3. I apologize, that should be a y over here. Now we can go ahead and flip both sides. I get y is equal to 3 over 1 minus 15x, which is c. Number 6, let f of x be the particular solution to the differential equation dy dx equals x plus 1 over y with the initial condition. Which of the following is an expression for f of x? So again, same type of problem we've already done a couple of. So I'm going to write this dy dx equals x plus 1 over y, multiply by y, multiply by dx. So I get y squared over 2. I'm going to go ahead and write that as 1/2 equals, this is going to be x squared over 2, or 1/2 x squared plus x plus c. Let's go ahead and plug in 0, negative 2. So I get 1/2 times negative 2 squared equals 1/2 times 0 squared plus 0 plus c. So the constant is going to be negative 2 squared is positive 4, divided by 2 is 2. Go ahead and put 2 in for c. We'll go ahead and double both sides of this equation. So I get y squared is equal to x squared plus 2x plus 4. And then I want to square root that. But again, remember, this could be positive or negative. Again, it all depends on that initial condition. But again, since that initial condition is 0, negative 2, then the only way when I plug in 0, inside here I get 4, the square root of that is 2. The only way to get that y to be negative 2 is if there's a negative out in front of the square root. So we get negative x squared plus 2x plus 4, which is c. Let's take a look at number 7. Which of the following could be the slope field for the differential equation dy dx equals x squared plus y? So again, there are several options we can go here. We can do something like this, that no matter what x is, x squared is going to be positive, and when I add y, that's what we're going to get for our slope. So I'm going to go ahead and just look at quadrant 1, where both x and y are positive. If I square x and I add the y, that should be positive. Okay? So in quadrant 1, where x is greater than 0 and y is greater than 0, then dy dx must be greater than 0. So if I'm looking right here, that slope in B is not greater than 0, therefore B is out. A, everything in quadrant 1 looks good. In C and D, everything looks okay. Now I'm going to say the same thing happens when x is less than 0 and y is greater than 0. Because when I square x, I'm still going to get a positive plus a positive. So x is negative and y is positive in quadrant 2. Okay, so in quadrant 2, dy dx should be positive. So let's see here. A looks good, B looks good, or C looks good, and so does D. So it takes care of quadrant 2. We could do something even. I could start off with, so you can go quadrant by quadrant. That would help. The other option is to do, and I've done this before with you, is to let x be 0 and y be 0. So what happens if x is 0? Then dy dx is y. So look at this here. On the y-axis, that's where x is 0, the slope should be equal to the y coordinate. So if I look at b again, which we've already eliminated, the slopes here are all 0. That means right here at y is 1, there should be a slope of 1. At 2, a slope of 2. At 3, a slope of 3. So we could have eliminated b for that reason. A, look, as we go up, those slopes increase. So A looks good so far. C down here looks good. It's doing the same thing. And D is doing the same thing. Now, if we look at C here, though, if y is negative, those slopes should be negative, and they're not. So right down here, we should want dy dx to be less than 0, since y is less than 0, and it's not. So C is out. Now, what happens if y is 0? If y is 0, now we're looking at the x-axis here, then dy dx is whatever the x is squared, which means dy dx better be positive on the x-axis. And if I look at A over right here, those slopes are negative. So A cannot be it. Therefore, it's got to be D. So again, there are a few different things you could do. Go quadrant by quadrant. Sometimes that helps. Take the axes. And there are a few other options you could do. You could even start your own little table and build and see what you get that way. All right, we'll continue with number 8 in the next video.